Welcome to Grade 3 Math Unit 2 Overview. This unit's going to talk about multiplication and division with sixes, sevens, eights, and multiplying with multiples of 10. So this is going to use a lot of the skills that you were working on in Unit 1, but it's going to go a little bit further. So keep practicing those math facts. That's going to help. And now's a good chance to take some notes and learn some of the new skills that you're going to need in this unit. All right, you should have your note sheet in front of you along with your notebook. All right, the first thing we're going to do is take a look at a multiplication table. This right here is organized for all your multiplication facts. On the outside here, we have all the different factors of 1 to 12. And across the top, we have the different factors from 1 to 12. Inside is all the multiples or the product of those factors. So if I do 1 times 1, we get our center 1. 2 times 1, 3 times 1, and so on. So we can use this chart to help us study and learn these multiples and these different multiplication facts. Now, one thing I want to point out to you on this multiplication chart is a square number. Now, if we think of a square, I might have to change colors here. If we think of a square, what do we know about a square? What identifies this shape versus any other shape? Hopefully you said that they have congruent sides. Congruent means that they are the same. So all these side lengths are the same. Now, if we're talking about a square number, we just want to be multiplying our side length or base times our height of the same number to keep it a square. So a square number could be 2 times 2, which is 4 here. If you notice down this row, all the square numbers are highlighted. 1 times 1 is 1, 2 times 2 is 4, 3 times 3, 9, 4 times 4, 16, 5 times 5, 25, and so on. You got your 6, your 7, your 8, your 9, your 10, your 11, your 12. So really it's just saying that if we are multiplying the area of a square, we need to have our two numbers equal or equivalent, just like a square would have. Looking at some mixed up multiplication tables. So notice that on the side here, we still have the gray, which are our factors. And then on the inside white area, that would be our multiples or our product. So we can start filling in this chart based on when we have two known things. So notice up here we have a 2. And over on the side, we have a 4. If we match those up to the square, that one would be 2 times 4, which equals 8. Let's give this over here a try. Now, the easiest thing to do is to work with two known amounts. So right here, I have a known factor of 5, and I have a known product of 25. So if I was thinking of this as a math mountain, I know the total and I know a part. I'm missing my other part. So in order to do this, we would want to plug my computer in there. We would want to find out the missing part. So 5 times what gets me to 25? And the answer is 5. So our other missing factor over here is 5. Now, because we found out what that was, we now can fill in this center circle or center square here. Our top amount says 4. Our very outside in the gray says 5, so this one's going to be 5 times 4. 5 times 4 is 20. Now we can keep going across our row. We have a 45 here, but we don't know a factor up on top. But we do have our missing factor from the side. So 5 times something gets me to 45. Or 45 divided by 5 is 9. We can keep going on this. We have a 5 on the top. We have a 2 on the side. So this is going to be 5 times 2, which is 10. Now, if I keep going down this row, I have a 35, but I'm missing a factor. The top factor said 5, so 5 times something is 35, or 35 divided by 5 is 7. Now, because I have that missing side amount, I can fill in this one. I have a 7 on the side. If I go all the way up to the top, it's a 4. So 7 times 4 is 28. This concept is probably pretty new to you. Feel free to keep rewatching this portion of the video when you try your practice problems. Our next concept is multiplication with tens. We can find the basic multiplication product and then multiply by the 10. So in this case, I can multiply the 2 and the 3 first. 2 times 3 is 6. And then I can count up how many zeros I missed. And in this case, I missed 1 0. So I'm going to have a 6 with that 1 0 to get my answer of 60. Let's take a look at some of the practice problems and how we would tackle these. So again, we're going to start with the two base numbers and forget the zeros. So 2 times 4 is 8. And then we forgot about 1 0. So we're going to add that 0 in because really we were multiplying by 40, not just the 4. So our answer is 80. Now this next problem has zeros in both the first and the last number. Again, we can forget about the zeros and just multiply our base numbers. So 5 times 3 is 15. Now, in this case, we had a 0 on the front number and we had a 0 on the second number. So how many total zeros is that? 2. So we're going to add in 2 zeros into our answer. Now, don't forget your commas. Ones, tens, hundreds, comma. So our answer is 1,500. Again, the next problem has multiple zeros in the front and back, so we're going to forget about those. 6 times 2 is 12. And how many zeros did we forget about? We got 2 in the front, 1 in the back, so that would be a total of 3 zeros we're going to add in. And then we put our comma in, ones, tens, hundreds, comma, thousands. So in this case, we get an answer of 12,000. Now, because we're working with our 6s, 7s, 8s, those are sometimes the harder math multiplication problems. But we could actually break our problem apart. And we call this the break apart multiplication method. So if we have the problem 7 times 8, we can break that apart into 4 times 8 and 3 times 8. Because 4 plus 3 equals 7. So if we know those basic math facts a little bit easier of the smaller numbers, we can do 4 times 8, which is 32, and do 3 times 8, which is 24. We then would just add these partials together to get what 7 times 8 is, which is 56. So again, we can break apart our models in order to make them easier. You're going to see something called a fast array drawings. Now, in the last unit, you learned what arrays were. These were these dots that made up rows and columns. A fast array is not going to draw out all of them. Instead, it's going to just do basic dot systems. So if we have a 64 in the inside of our fast array, we know that that is our product or our total. And then we have an 8. An 8 is on the outside. That one is our factor or our part. We are missing one of our factors or parts. So again, we can always think of these as like the math mountains, where we have our total, 64 is on top, and we have 8 on the side, bottom, and we're missing the other factor there. So we can look at this in a couple different ways. We could do 8 times what gets me 64, or 64 divided by 8 gets me what? And in this case, our missing factor is 8. Let's try some of these examples. Feel free to pause the video if you think you've got this and then check to see if you're right. Otherwise, just continue on and see how we solve these problems. So our 6 is a part. Our 5 is a part. So we know we are going to just multiply these together to get our inside amount. 6 times 5 is 30. Again, you could have broken that apart if you needed to and done 5 times 3 and then 5 times 3 and added those two together to get our 30 if you're struggling with these. 56. 56 divided by 8 gets us our part because 56 was our total, 8 was a part, and we're missing our other part. So in this case, division makes the most sense. So 56 divided by 8 gets us our answer, and our answer is 7. Moving on to area and perimeter. Perimeter is the outside of an object. This is a great time to think of like if you're going to put a fence around an object and you need to know how much fence to put on, or you want to put a ribbon around the border and you need to know how much ribbon to buy. In order to find the perimeter, all we do is add all of our sides together. Our label for perimeter is just units. Because we were just walking in straight lines, it was one-dimensional. Our labels could be feet, yards, miles, inches, meters, things of that sort. If it doesn't identify the label or the unit, then you can just use the word unit. Area is the inside amount of an object. This is used if you're going to cover a wall in wallpaper or carpet your floor or put down flooring. Then you might need to know the area of it, the inside amount. Now, a lot of times you'll hear this as length times width. I like to change this one up to base times height because when we start getting into other um, geometric shapes, we really use the terms base and height a lot more often. The base is what the shape is resting on, and the height is how tall it is. The height needs to be 90 degrees from the base, and it always needs to be 90 degrees from the base. Sometimes you'll see a height drawn in with a dotted line to show you that that's the 90 degrees from the base portion. So we are going to multiply our base number times our height number to get our answer. This one, because we're finding two dimensions, base and a height, we're going to use a label of square units. It could be square feet, square meters, square yards, square miles. But this one does need to have the squared on it. Another way to write squared could be like U with a little 2, or we could even abbreviate square of SQ dot, and then whatever your unit measurement is. If you don't know it, it would be just U dot. So either of these are also acceptable compared to writing out the whole label. Let's take a look at some of our examples. A sign covers 12 square feet. Now, I like to make a drawing because visuals usually help. Now, 12 square feet, because it uses this label of squared feet, I know that that already is my area. That's my inside amount or my total. The sign is 4 feet long. So I can put 4 feet here, and I'm going to put in the feet labeling. How wide is the sign? Well, I have a total and I have a part. So if we were going to solve this, we're going to use division. 12 divided by 4 equals how wide? So I'm going to say W. And W is going to equal whatever 12 divided by 4 is, which is 3. And because this is only a length, it's one dimension, it would be feet. So my answer is 3 feet. Now we had to know the equation for area in order to solve this problem. If we wanted to put a border around this sign, we then needed to find out that missing length. So we have a 4, we have a 3, which means this opposite side is 3 and the top would be 4. If we were putting a border around it, that's the perimeter. So we would do 4 plus 4 plus 3 plus 3 to get our perimeter amount. 4 plus 4 is 8. 3 plus 3 is 6. So if we add those two amounts together, we're going to get 14. Now, because this was one dimensional, it's just going around, it would just be the label of feet. The only time we're squaring our label is if the answer is the area. All right, our next concept is PEMDAS, or order of operations. Order of operations is the actual name of this method. Now, some would argue PEMDAS is not always the correct way to teach it. Your parents probably learned it as "please excuse my dear Aunt Sally," and that used the different letters of PEMDAS too. So your first step always is to do the parentheses. Your second step is going to be to do exponents. Now, in third grade math, we really don't have exponents yet, so we don't need to worry about that step. The next step is multiplication and division. Now, this is where people don't like the term PEMDAS because we do multiplication and division from left to right. That means we might actually divide before we multiply. Same with addition and subtraction. That is our fourth step. We do them at the same time, but we go from left to right. So we might actually do subtraction before addition, depending on where they show up. Now, let's take a look at how we would tackle these problems. So the first symbol I see is addition, so I'm going to put an A there. The next symbol is multiplication, so I'm going to put an M there. Now we can kind of utilize this PEMDAS method. Which step comes first? P, we don't have parentheses. E, we don't have exponents. MD, oh, I see an M. So I'm going to solve that first. 4 times 2 needs to be solved before we do the addition. Now I like to show these little brackets and bring it down. And I keep everything else in order of how you see it. This is really important, especially if you get into subtraction. Now I'm left with my last step, 5 plus 8. And I know that 5 plus 8 is 13. So my actual answer is 13. Let's take a look at the next one. I'm going to change colors so that you can see it a little different than what we just did. So our first symbol is division. Our next symbol is addition. So this problem is actually written in the correct order of how I would solve it. But math isn't always solved from left to right. So I'm going to do the division first. 8 divided by 2 is 4. And then I'm going to rewrite the plus and the 2 because I haven't used those yet. So we just brought those down. And now we get 4 plus 2, which is 6. If we do these math problems in the wrong order, we will get the wrong answer. All right, our last problem, we'll change colors again so that you can see it different. We have a multiplication symbol. We have a subtraction symbol, but inside the subtraction symbol here is our parentheses. So we are going to do the subtraction first because it's inside parentheses, and we do all parentheses first. 8 minus 1 is 7. And then we pull the 6 and we pull the times down. And then we can solve the problem of 6 times 7, which is 42. All right, now's the time to try the practice problems on the bottom of your sheet. If you feel confident, pause the video and try it on your own. Then resume the video and check your answers. If you're still struggling, feel free to go back to the beginning of the video and rewatch any of the concepts on this page. Resume the video when you're ready to check your answers or see how to solve the problems. All right, our first example, we had a 5 and a 30, so our missing amount was a 6. We then can do 6 times 2, which is 12. And then we had 6 already and a 48. So 48 divided by 6 gave us our 8. We had the 4, we had the 5, so we can get to the 20. We had the 5, we were missing the 9. So 45 divided by 5 is 9. We now have the 9, and we had the 2, so we can get to the 18. Moving over to example 2, using our fast array drawings, 45 divided by 9 got us our missing part of 5. And 6 times 6 gets us our missing amount of 36. The next part uses our PEMDAS. So if we have an addition and we have a multiplication, what's the first step we need to do? It's the multiplication, not the addition. So this one would be false. The next one, we have a multiplication. We have a division. So remember, multiplication, division, we go from left to right. So we're going to do the multiplication first. And that's what it said to do. So that one is true. And the last one, we have a parentheses and then a division sign. So we're going to do the parentheses first. So yes, we do the 9 minus 4 first. So that's a true. Write an equation and solve. Sometimes these ones can be tricky because this was a multi-step problem. So Angela had $4. She bought 2 small pumpkins for $1 each. Remember, if we see the word each, that means to multiply. So we do need to do 2 times 1. And I'm going to put that in parentheses, even though it really did not need the parentheses. Because if I took the parentheses out, I still would have to solve my 2 times 1 before I did the subtraction. But then to solve it, I do 4 minus, I would have gotten 2, and I get 2 as an answer. Number 5, give an example of a square number. Remember back in our multiplication chart at the very beginning of this video, square numbers are anytime we multiply a number times itself. So 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 25, some remaining numbers 36, 49, 64, 81, and so on, as long as you multiplied the first number by the same as the second number. I excel if you use the skill plans. Going to grade 3, unit 2 will help you prepare for this unit and give you some extra practice. Also, check out that math activity center, the lesson checks. Rewatch this video if you need any additional support. Otherwise, good luck on Unit 2.